Have you ever wished you could, just download knowledge directly into your brain? Really grasp the core of a subject from a book and instantly understand it?
That's a fascinating idea. It kind of touches on the incredible potential of the human mind for absorbing and truly owning complex information.
Well, that's exactly what we're diving into today. We're exploring what we call book-to-brain learnography. It's all about how some really extraordinary people throughout history, like geniuses in their fields, became incredibly knowledgeable and made groundbreaking discoveries mostly through their own self-directed learning from books.
Right. And we've got some really cool material here that delves into this unique approach and the fundamental principles that made it so powerful, so effective.
Our mission today is to really dissect these key insights from our sources, explore some truly inspiring examples, and figure out, what made this book-to-brain method so incredibly successful.
Yeah, exactly. It's like offering our listeners a shortcut to understanding how to learn like these amazing figures.
And it's an encouraging thought, right, that our brains actually have this built-in capacity to learn independently. We absorb information, organize it in our own way, and then use it in the world around us, often without needing formal instruction.
Absolutely. History is full of examples of incredible self-taught thinkers. People who revolutionize science, mathematics, even leadership. They really embody this type of learning in its most powerful form.
So over the course of this deep dive, we're going to be looking at some of the main themes our sources highlight. Like, how did these great minds actually master knowledge through books? What's the science behind this whole book-to-brain concept? And who are some of these remarkable people? Plus, we'll touch on the actual cognitive and neural processes happening in the brain, the fundamental principles we can take away from all this, what it all means for learning today in our modern world, and ultimately how transformative this whole approach can be. Okay, let's jump in. So what exactly is this book-to-brain learnography thing?
Well, in essence, book-to-brain learnography describes this active process of transforming knowledge from books into, you can think of them as brain page modules. Now, these aren't physical pages, of course. They're more like mental frameworks that you build in your mind. These frameworks allow you to have a deep, nuanced understanding of a topic, effectively store that knowledge over the long term, and then easily apply it whenever you need to. It's about fostering independent learning through this active brain page development. And something that's really interesting is the role of what's called motor science in all of this.
Motor science. Now, that sounds like we're talking about physical movement. How does that tie into reading?
Great question. It highlights a really important aspect of the science behind all of this. So brain page theory proposes that learning isn't just about passively absorbing information like a sponge. When we learn, that knowledge is actively converted into neural patterns, electrical and chemical signals in your brain. These patterns are stored in specific areas like the hippocampus, which is crucial for forming memories, and the cerebellum, which is often associated with coordinating movement.
Okay.
Now, the big difference between simply reading a more passive activity and actively engaging in book-to-brain learning lies in something called motor-driven engagement. This is where things like physically writing notes, working through problems related to what you're reading, even mentally practicing and visualizing the concepts come in.
So it's not enough to just read the words on the page. You
Yeah.
have to actively do something with that information.
You got it. This active engagement really fires up those cerebellar circuits in the brain. It's similar to how we develop motor engrams when learning a physical skill like, let's say, riding a bicycle. The more you practice, the more ingrained those movements become, almost automatic. So applying this to learning from books, this physical interaction, writing things down, manipulating ideas in your mind, it really strengthens those long-term memories.
Yeah.
Motor science, in this context, emphasizes how crucial these cerebellar learning circuits are, not just for movement, but for acquiring and truly retaining knowledge.
Interesting. So when you actively engage, like writing out equations when you're studying physics, doing a mental simulation as you read history, or creating a visual model in your mind, that's what really makes the information stick and become easily accessible later on.
Yeah, exactly. It seems these self-directed learners kind of intuitively understood this. They use this repetitive practice and mental visualization without even realizing it, which helped them achieve much deeper understanding and recall.
So it's not just one part of your brain that's involved. It's a whole network working together to process and store information.
Okay, I'm starting to see how this all connects. Our sources provide some incredible examples of individuals who really seem to have mastered this book-to-brain approach. Let's start with Michael Faraday. Here's a guy who started as a simple bookbinder's apprentice and ended up making huge discoveries in both physics and chemistry.
Faraday's story is truly amazing. Even though he didn't have much formal schooling, he was an absolute bookworm when it came to science. He devoured scientific texts, attended public lectures whenever he could, and this is crucial. He meticulously documented every single experiment and observation he made.
He was very organized and thorough in his approach. Oh, absolutely. It wasn't just about passively taking in information. He was actively wrestling with these complex scientific concepts. He was always striving to truly understand them. It's like he was building his own personalized brain page modules for these ideas through constant hands-on experimentation. Picture him in his lab, always testing, tweaking, and meticulously recording his findings. That constant active engagement is what really solidified his understanding.
And that link between theory and actually applying it seems like it was key to his success. Our source highlights how his ability to translate what he read into actual, tangible experiments really shows how effective this cerebellar learning can be in scientific discovery. It wasn't just abstract theory for him, it was something he could test and manipulate.
Exactly. He was taking those ideas off the page and bringing them into the real world. That process would have deeply ingrained those scientific principles in his mind, both in his understanding and in his memory. Now, speaking of amazing minds, we've got Srinivasa Ramanujan, the brilliant mathematician. His story is almost legendary. He basically taught himself advanced mathematics just by thoroughly studying a single book.
A synopsis of elementary results in pure mathematics, right?
Yeah.
Not exactly your typical textbook. And from that, he developed this incredibly deep, almost intuitive understanding of really complex mathematical concepts with barely any formal guidance.
It's mind-blowing. And what's truly remarkable is his relentless focus on problem solving. He'd work through math problems over and over again. It's like he was building these intricate brain pages for complex mathematical ideas purely through sheer dedicated practice. This seemingly effortless grasp of complex theorems. It's like a perfect example of cerebellar motor learning, but applied to this abstract world of mathematics. Through this incredibly intense self-directed practice, his brain essentially internalized the very patterns and structures of mathematics. It's like a musician practicing scales over and over until they become second nature. Ramanujan did that with mathematical problems.
Wow. It's like his mind was a finely tuned mathematical instrument, constantly being honed and refined. Now let's move on to Ada Lovelace. She's widely recognized as the world's first computer programmer for her groundbreaking work on Babbage's analytical engine.
And Lovelace's engagement with mathematical and technical texts went way beyond passive reading. She'd write these incredibly detailed annotations, not just trying to understand, but actually developing algorithms, the step-by-step procedures that form the basis of computer programs.
So she wasn't just grasping how the machine works. She was figuring out the logical processes to make it actually perform tasks, basically the core of programming.
Precisely. Her approach perfectly embodies that motor-driven knowledge transfer and brain page development, but in the realm of computational thinking. The very act of writing out those algorithms and visualizing them in action would have imprinted those concepts onto her mind, strengthening those specific neural pathways related to computation. It's really fascinating.
Then we have Abraham Lincoln. Despite having very little formal education, he became a brilliant lawyer and, of course, President of the United States. His learning journey is pretty amazing in itself.
Lincoln's approach was fascinating. He'd read legal texts repeatedly, he'd write about them in detail, really internalizing those core principles of law. It's a perfect early example of this self-driven approach to learning, right? His disciplined method, even without much formal instruction, transformed all that information into practical wisdom that he could then apply in his legal career and later as a leader. You can see how that consistent active engagement built this deep and practical understanding.
And finally, Leonardo da Vinci. The ultimate Renaissance man. Art, science, engineering, he excelled in so many areas. And he was largely self-taught, relying heavily on books and his own meticulous observations of the world around him.
Da Vinci's notebooks are like a window into his mind. They're packed with detailed sketches, diagrams, and experimental notes on such a wide array of subjects. He wasn't just reading about anatomy or mechanics. He was actively exploring those areas, through drawing, hands-on experiments, and documenting everything.
It's amazing to think about.
His seamless integration of book knowledge with his practical hands-on exploration beautifully illustrates how cerebellar learning can support expertise across so many different fields. It's almost like his learning wasn't confined to any one area. It was constantly spilling over and enriching other domains.
So it seems like with all these extraordinary individuals, there was this consistent active engagement with what they were learning. This drive not just to passively absorb information, but to wrestle with it, make it
Mhm.
their own, really internalize it. Let's dig a little deeper into the why behind all of this. What are the actual cognitive and neural mechanisms that make this book to brain approach so incredibly effective?
So a crucial player in all of this is the thalamus. You can think of it as this central hub for information in your brain, sort of like a grand central station. It filters all that sensory input coming in from the world around you and then sends the most important information to the cortex for higher level processing. And this processing is essential for turning knowledge into understanding and storing it in your memory. Now, for those self-driven learners who are really active with the material through writing, practice, mental visualization, this repeated motor interaction seems to strengthen those neural pathways between the thalamus and the cortex. This improved connectivity helps the brain prioritize and consolidate that information into long-term memory.
So, the more we actively engage with the information, the clearer and stronger the pathway becomes to the parts of the brain responsible for memory.
Yes, that's a great way to visualize it.
Yeah.
And then, of course, we have the cerebellum, which we talked about earlier. While its primary role is usually seen as coordinating our physical movements, it also plays a big part in regulating different cognitive functions like attention and learning. So in the context of this book-to-brain learning, when you're physically doing something related to what you're learning, whether it's writing out mathematical proofs, building a model, even mentally rehearsing a sequence of steps, you're activating those cerebellar circuits. This reinforces something called procedural memory, the how-to knowledge. But it also seems to make it much easier and faster to recall the what knowledge, the actual facts and information later on. It's like those physical actions create this additional super efficient pathway to access that information.
It's amazing how all these different parts of the brain are interconnected in this intricate dance of learning. Now, based on these incredible examples and what we know about the brain, what are some of the core principles we can actually learn from all this and use in our own lives?
Well, several key principles emerge. First, there's self-driven curiosity. All these amazing individuals had this intrinsic, powerful desire to learn, just for the joy of it. No need for external pressure or rewards. It was pure intellectual hunger.
They were just fascinated by learning.
Exactly. Second, there's brain page making. That's the active process of converting book knowledge into those personalized mental frameworks we talked about earlier. Techniques like active recall, putting things in your own words, and repeated practice all play a role. Then there's the third principle, which we've touched on quite a bit. Motor-driven knowledge transfer, actively engaging in visible tasks related to what you're learning. This reinforces those cerebellar pathways and dramatically improves comprehension and retention. And lastly, there's the importance of personalized learning. Each of these individuals adapted their learning to their own strengths, their preferred style, their goals. There wasn't this one rigid method that everyone followed.
It really emphasizes that learning is a deeply personal journey, not a one-size-fits-all kind of thing.
Okay, so we've learned a lot from these historical figures, but what does it all mean for learning today? How can this influence our modern educational systems, or even just how we learn more effectively on a personal level?
The book-to-brain model challenges a lot of traditional teaching methods that still rely heavily on passive learning. Lectures and rote memorization. This model suggests a really exciting possibility for what our sources call brain page classroom learning environments that prioritize independent knowledge transfer, where students are actively building their understanding rather than just receiving information.
I like that.
And there's huge value in incorporating more motor engagement in learning. Think hands-on tasks, experiments, active problem solving, anything that gets students actively involved and stimulates those cerebellar learning circuits.
So getting away from just sitting and listening and moving towards more interactive, engaging learning experiences. Exactly. And maybe most important of all is the need for personalized learning paths. This is where individuals are empowered to pursue their own interests, those things they're genuinely curious about, and build those unique brain pages in a way that resonates with their own learning style.
So it's about shifting from being a passive consumer of information to becoming an active creator and builder of your own knowledge and understanding. So as we wrap up this deep dive, we've explored these amazing journeys of Faraday, Ramanujan, Lovelace, Lincoln, and Da Vinci. Their lives really show the incredible power of this book-to-brain learnography.
Absolutely. Their achievements show us that self-directed learning, when it's rooted in active engagement, building those personalized brain page modules and applying those motor science principles, it's such a powerful model for achieving deep intellectual mastery and making a real impact on the world.
So for you, our listener, this isn't just an interesting history lesson. It's a call to action. We encourage you to embrace this idea of self-driven learning. Take a more active role in your own learning journey. Don't just passively take in information. Engage with it. Get your hands dirty. Experiment.
Yeah. Start thinking about how you can actively build your own brain page for the topics and skills you want to master. Don't just read. Transform that information into something you can use. Try motor-driven techniques like writing summaries in your own words, tackling problems, experimenting in any way that makes sense for the topic.
And maybe this is a good time to look at those passive learning habits we might have picked up along the way. Maybe it's time to challenge ourselves to engage our brains more fully and actively using those principles of motor science. Here's a final thought for you to chew on. Think of one area you've always wanted to learn more deeply about. How can you apply these book-to-brain principles to that? Instead of just reading about it, how can you actively engage with that information? Maybe by writing, trying to apply it, truly building your own deep understanding from the ground up.
It's an exciting challenge. It's about taking ownership of your learning journey
Exactly.
and unlocking the incredible potential of your own mind.
Well, that's all the time we have for this deep dive. We hope you found it insightful and, more importantly, inspiring. Until next time, keep learning and keep exploring.
And keep building those brain pages.
See you next time.